All right, welcome to the deep dive. Today, we're analyzing a really crucial piece of professional hardware, the Thor Broadcast H-SPARTAN-2. Our mission here is to figure out how this thing really works as a kind of central hub for video. I mean, think of it like a specialized cargo processor. It's taking in all this different video cargo.
I'm all over the place.
Exactly. Packaging it up efficiently and then sending it out on completely different network tracks all at the same time.
Yeah, and the context here really matters. This isn't consumer gear. It's offered by HDTE Supply, and maybe more importantly, it's TAA compliant.
Okay, what does that mean for someone listening?
It just means it's built to a standard for, say, government or serious institutional use. Reliability is basically non-negotiable.
Okay, so let's unpack this thing, starting with the inputs. This is where it gets really interesting. You get 4 dedicated HDMI inputs plus 4 CVBS inputs.
And that CVBS part is the golden nugget, isn't it? I mean,
Right.
CVBS is that older analog video.
Right, like old security cameras or legacy equipment.
Exactly. So by putting 4 of those right next to 4 modern HDMIs in one box, you're solving this huge headache of bridging the old world with the new.
That's incredible utility. And speaking of the box itself, it's a 1RU chassis, internal power supply. But I saw it has a separate USB input. What's that for?
That's a really smart workflow shortcut. It's not for storage. It's specifically for TS to IP streaming. So you can play a pre-encoded transport stream file directly from a USB stick.
So you can bypass the physical inputs entirely for testing or playback?
You got it.
And what about control? It has the usual LCD and web interface, but why a dedicated NMS and network management system port with its own IP address?
It's all about stability.
Yeah.
You want your main video stream to be completely untouched, right? So you put all the management, all the monitoring on a totally separate, dedicated line, no interference.
Okay, so that brings us to the engine room, the encoding. It's using H.264.
The old reliable. AVCHP at L4.0 specifically. It's the workhorse that gives you great quality without, completely crushing your bandwidth.
And the audio is just as flexible. MPEG-1, L2, AAC, AC3.
Which you need because the destination dictates the codec. And this thing is built for multiple destinations.
Which is where the dual streaming comes in.
This is where it gets really fun. For your internal network, your LAN, it uses things like UDP and RTP multicast. Super fast, super efficient, low overhead.
But for the public internet?
For the WAN, you need HLS, RTMP, HTTP. Those are the protocols that let you stream with low latency directly to places like YouTube or Facebook, just by plugging in an RTMP key.
Let's talk about performance for a second. The specs say it can take in a full 1080p at 60 frames per second.
Yep.
But the maximum output is 1080 at 30 frames. Why the drop? Is that a technical limitation?
No, I'd say that's absolutely a strategic decision. It's built into the hardware to guarantee stability. By halving the frame rate, you dramatically reduce the bandwidth you need.
And that matters when you look at the bitrate controls.
It's the whole story. For that local UDP stream, you can push up to 14 megabits per second. But for the public RTMP stream, you're capped at 8 Mbps.
That's a huge difference.
It is. It's an engineering trade-off for reliability. You just can't risk dropping frames on a public broadcast.
And the value is all wrapped up in that. I see the MSRP was around $2,400, but it's currently listed at just under $2,000.
And for that price, with a 2-year warranty, you're not just buying inputs and outputs, you're buying a tool that manages risk and, frankly, future-proofs your setup.
So what's the bottom line here for you? The H-SPARTAN-2 is basically a translator. It takes old analog and new digital and creates a single high-performance IP stream that can go anywhere.
Exactly. It's a bridge, which, brings us to a final thought to leave you with.
Okay.
If you can stream internally at a high-quality 14 megabits per second, but you're strategically limited to 8 megabits for the public internet, how does that change your content strategy? Do you save your absolute best, most detailed video for internal use and only send the more compressed version out to the world? That's the real optimization puzzle this box forces you to solve.